So, our conversation today is an introduction to volume, another term that I know that you have some familiarity with, but we are moving away from surface area into this discussion on what it means to find the volume of a shape. So, I'm bringing back my cereal box analogy. I think it's fun. Captain Crunch is another one of my favorite ones. And I just want you to stop and think when you go to fill up a cereal box, and the box is empty, you're starting to fill it up, where would that first piece of Captain Crunch go? Where would the first piece fall? Hopefully, you know a little bit about our friend gravity and know that if you had your hand up here at the top of the box and you dropped in a little piece, this is this little dot here to represent my Captain Crunch, you dropped a piece into the box. Hopefully you were able to tell me that it travels all the way down to the bottom of the box and hits the bottom, or the base, to use that geometry term. And as you start filling the box, everything continues to go down. So what happens is down here at the bottom of the box, this whole bottom layer will start to get filled first. And then until that whole entire floor or base of the box is covered, only then will the box start to fill up all the way to the top of the box. So we start by filling in the base, or the bottom where everything is going to travel, and then we work our way up the height of the shape. So I'm hoping this is helping you just kind of see, whether you realize it or not, the activity that I just had you do, you're just about there. You have almost already solved for volume with the activity and the pieces that you've done on the page in front of you. So you've already come and you've checked your answers with me. I'm going to show you here just my answer key that's up here. You found the base. You should have highlighted the base. And again, I want to just make a note that in prisms especially, the base does not necessarily mean what it's sitting on. Here in this first example, the base is in all of these, it's the non-rectangular surface. So right here is what we're looking at for the base. And so it's not sitting on the base at the current moment. But if it was, we would have a triangle here at the bottom, and then a shape going up to the very top, and then the height would be coming here. So if cereal boxes for some reason started becoming triangles instead of rectangles, this is how it would stand, with a triangle sitting on the bottom. Which means that in order to find the volume, we need to find the area of the base. Where are those cereal pieces going to fall first? And that's here on the base, whether again it's what it's resting on or not. And then it's just going to be layer after layer after layer of that area just piling on top of each other for the whole height of the box. So hopefully you're starting to realize why it was that I made you calculate the area of the base. That is your initial layer where all the cereal or whatever you're filling is going to fall. And then that layer is just going to continue up the height of whatever solid you're dealing with. So you see on your paper, and I know it's not here on mine, but you see item D down here, and you're supposed to leave that blank until that point, because here, D, we are going to find the volume of each of these prisms. You've already done the grunt work. There's just one final step. In order to find volume, and I want you to write it up here in the corner, volume, the formula that I need you to know, and I know that the formula sheet says other things, in order to find volume, you need to find the area of the base, and I'm just going to write that as area of B, because that's going to change. You see all of these prisms that you looked at, we had some triangles, we had some trapezoids, it's always going to be different. So to keep it generic, you need to find the area of the base, like you did here in step B, and then you need to multiply that by the height of the prism, or the object that you're dealing with. So in other words, how far, and we've practiced this with surface area as well, how long is the piece that connects the two bases? So really, in order to find volume of each of these pieces, we need to take what we found in part B as the area of the base, so in this case it was 12, and we need to multiply it by what we found in part C, which is the height, which was also 12. So 12 times 12 gives me a total volume of 144 centimeters. In this case, and in volume only, we now use what we say cubed. This is 144 centimeters cubed because we now have 3 different dimensions working together. We're talking about a 2-dimensional area surface here of the triangle, and then adding the 3rd dimension by adding the height to that 2-dimensional shape. So really the step that I want you to take, and then you'll come and check in with me, is I want you to go through and calculate D for each of these prisms. And again, in order to find volume, you need to take the area of the base. I used a capital B, the base of this shape, which will be a 2-dimensional figure. You'll always have to go through this process. So the area of the base, and then multiply it by the height for each of these examples. Once you have gotten D for all of these, there's only 5 left for you. Come in and check in with me, and I'll sign off. You'll be good to go.